And we are good. Okay. Students, this is Unit 7, Circles, Lesson 7.4, Undercover Right Angles, Part 1. There's 2 parts to this. You're taking a look here. Don't forget to get a parent or guardian sign off. Let's take a look at this review problem. It says in the circle below, the diameters of A, B, and C are, so A is 10 centimeters, and that's the diameter, 10 centimeters, so I'm going to do that in red. And then B is going to be 20 centimeters, the diameter, let's color code these. And then C is going to be 14 centimeters. Your goal is to find all possible segment lengths. So let's get that filled out. This is 10 centimeters, this is 20 centimeters, and this is 14 centimeters. Ready? I'm going to give you a minute to find everything possible. Your goal is to find all possible segments right there. All righty, let's take a peek here. Let's see what we got. And we know that this from here to here is going to be 10, and this is 10, and this right here is 7, and this is 7, and this is 5, and this is 5, and then you want to look for overlapping stuff. Did you guys get that little guy? What'd you have? 5. And what about this little guy? 3. Yeah, you got it. You got it. All right, let's get your reference booklets handy because you're going to need them in just a little bit. So this lesson is all about an undercover right angles. We're going to be talking about tangents and radius, chords. I'm going to talk specifically about the tan-tan angle, the tan chord, and those right angles are going to come back to haunt you again. Now let's go through, you got to use your imagination just a little bit here. This is the ground, so just trace this. Now that wheel touches the ground at a certain point. And remember, when a circle touches, that is a point of tangency. So we're going to call that a point of tangency. Now imagine this wheel is rolling, and that's a radius. Now imagine that radius, you have this radius that goes to the point of tangency. That's also a radius, and it touches the point of tangency. Ready? I want you to trace a couple things for me. I'd like you to trace the tangent, trace the radius, trace the tangent again, trace that radius. Ask yourself, what kind of angle feels like it's there? I'll ask you this. What is it? Bingo. You should have said a right angle. And that just changes the game there because we now have circles with right angles. I have a little jingle here for you to remember this. Okay, I'd like you to draw a first darken the point of tangency. We're going to do a little point right there. Now draw a tangent at that point. Okay, ready? I want you to put your pencil down and just watch as I sing. I'm going to trace stuff, but I just want you to watch it the first time because I'm going to sing it. And I'm sorry, I'm about to adulterate a very beloved nursery rhyme. This is Mary Had a Little Lamb. So just watch for the moment. If tangent to a radius, 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 if tangent to a radius, right angle at the edge. Ready? Pick up your pencils. Get ready to sing with me. Ready? If tangent to a radius, 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 if tangent to a radius, right angle at the edge. Emphasize that word edge. There's a reason there. That is very important. It's right angle at the edge. This is your first, what I call undercover right angle. Undercover right angle. So students, this really changes the game because honestly, what this means is now you're going to have a bunch of circle problems, which are actually undercover right angle problems. Ready? For example, in circle O, AB is a diameter. So let's trace the diameter. AD is a tangent segment. So why don't you just trace and stretch AD out? That's a tangent. I'm going to give you 1 minute. I want you to find as many right angles as you can, but just because I say right angles plural, it doesn't mean it is plural. But see if you can find any and all right angles. You have 1 minute, go. Actually, I'm only going to give you 30 seconds because it should be that quick. Ready? Find all possible right angles, go. All right, let's see how you did here. Yeah, okay, so take a look here. Okay, so the first one was if tangent to a radius, 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 if tangent to a radius, right angle at the edge, there's one there. Technically, there's one right on the other side. But where's the third one? Okay, watch out. That is 180, right? And then this is an inscribed angle. Boom, right there. So you got to write out. There's now 2 ways you can get right angles. One, an inscribed angle in half a circle, and tangent to a radius, right angle at the edge. Let's do a couple here. I'd like you to trace and sing with me here. Okay, so we're going to make any right angles that we can. I'm going to trace the tangent. Now trace the radius that meets the tangent. Now this looks really complicated, but if you sing, you'll know exactly where to put it. It goes like this. If tangent to a radius, 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 it's tangent to the radius, right angle at the edge. Boom, there's your right angle. Now I'd like you to trace a right triangle. That's where this is going to come into play, is your right angles are going to play into right triangles. Let's do a couple examples here. We'll do 2 of them. Ready? I want you to take 30 seconds in this one and just find the right angles. That's it. Find the right angles. You got 30 seconds. Go. Try to find the right angles there. Okay, so if you take a look here, we have this segment RS is actually tangent to both circles. So tangent to a radius, and there's a radius here, right angle at the edge. So you should have gotten 2 right angles there. 2 right angles. I take that back, 4, because they technically should be on the other side. All right. Now let's actually figure out how this can help us start solving stuff. Take a look here. We have Q's the center. Let's trace QR the radius. Now trace QT the radius. Ask yourself, trace QR again. Trace QT again. Do you see those are equal? Because they're radii, so mark them equal. Always mark your radii equal. So right off the bat, bring that 12 feet over. Why? Because all radii are the same length. And it says trace RS. And trace QR again. Our goal is to find X, which is right here. So it doesn't look like you can do anything with this unless you have a right triangle, which, sing with me, if tangent to a radius is tangent to a radius, right angle at the edge. Okay, so let's take, we actually have a right triangle going on here. Let's pull that out right here. There's our right angle. This is Q. This is R. This is S. So watch really carefully. QR is 12. RS, we don't know. Now I'd like you to come over here. I'd like you to bracket Q all the way to S. Warning, that's not 12. You've got 10 seconds to figure that out. What is it? Hmm? Trace it. Trace. What is it? Uh-huh. Trace. Nathan, what is it, Nathan? Almost. This is 12, and this is 8. Oh, funny. Yeah, brains in the hand. Okay. On that note, we're going to be doing leg, and here's the hypo. Okay, this is not a 45, 45, 90, but we do have 2, so we're going to do leg squared. And circle plug tug. So we have 1 leg, it's 12 squared. Our other leg, we actually don't know. Our hypo, we do. Let's actually try to do the math. 12 times 12, you should know by heart, is 144. X squared. 20 times 20, you can do over here. Is 400. Okay, now we're going to minus 144 both sides. So we have x squared equals, no, it's not. Don't mess with me here. 400. What did I get? Yeah, because you're borrowing 3. You're borrowing again. And yeah. Okay, it's 256. And I know that's a perfect square. We start factoring, I'm pretty sure that's 14. So 256 square root, oh, but 16. So you just found our x, which is 16. Okay, one more simple, and then we'll do a couple problems on our own. Right here, this is a tangent angle. Remember that's here, that's tangent. Draw a big fat dot at the point of tangency. From here to here, big fat dot, point of tangency. This is called a tan angle. There's a couple really important properties here. Ready? DCB, just trace it. DCB is a tan angle. Imagine if you were the person and you are holding with your hands here, a beach ball, and you ask yourself, what would you know about the length of your arms? Like this, length of your arms. You put your arms out, you're holding a beach ball, you're like about to launch a beach ball, you should feel it. Your arms are going to be equal here. So when you have a tan angle, the arms of the tan angle are always going to be equal. So ready? Darken your point of tangencies, draw your tan angle. We have a point of tangency here. We're going to find what we can find. We're going to start by solving for x. The arms are equal. So I know in this case, 4x minus 9 equals 15. Solve. So we found x equals 6. We also know this length is 15. And we have two right angles here. Okay, let's come over here. So take a peek here. These are a bunch of tan angles. I'm going to trace them with you, and I'm going to set the timer for 2 minutes, and you're going to find what you can find. So it says right here, trace AE and AD. So let's trace AE and AD, points of tangency, and those are going to be congruent. Now trace BE and BF. BE and BF. That's another tan angle. Notice the hatch marks. And trace CF and CD. Says right here, now that you've done all that, find the perimeter of the triangle ABC. Find the actual perimeter there. You have 2 minutes, go. Okay, is it on? Okay, my audience is done, so hopefully most of you are done at home. You should have gotten that. If that's 6, that's 6, that's 4, that's 7. You add them all up. That's going to be 12 plus 8 plus 14. And I think the consensus here, it's 30, 34 it is. Yes. Okay, watching out for the arms of the tan-tan angle. Let's go to your reference booklet. We're going to catch up. You want to find Unit 7. This is where we left off on. We're going to quickly recap. Recap the angles that we did in class recently. We're going to add just a few things here. So here we have a tan chord. And it's a tan and a chord. And a tan chord is the same as the one inscribed. So that angle equals half the arc it's facing. Angle equals half the arc. That's tan chord. Tan chord angle is the same as the one inscribed. Notice the songs are right there in the box. Next one, a chord angle is half the sum of the arcs it strives. So that angle, which those are equal, these two pink angles are equal, but it equals this arc plus this arc over 2. So that's how it goes. A chord angle is half the sum of the arcs it strives. The next 3, the vertex is outside. Same position, same equation. If they have the same position, they're going to have the same equation. That's right. So secant goes through. That's a secant, tangent, secant, and a tan-tan. I'm going to put one bracket here because all 3 of those have the exact same equation. And it's angle equals. And it's going to be the big arc, which in my case is the blue one. Big arc minus the little arc over 2. That's secant, tangent, tan angles are all the difference, that's subtract of their arcs multiplied by half or divide by 2, same thing. All right, that's recap. Let's do what we did today. We'll come back to that. This little section here is, oops, I skipped a page, right? There it is. Taking here, look at the lamb. Look at the lamb. Yeah, it's reference booklet. Find the lamb. And the song goes like so. If tangent to a radius, if tangent to a radius, right angle at the edge. Just to recap, that's if tangent to a radius, if tangent to a radius, right angle at the edge. It actually is on both sides. Excellent. Yeah, yes. Which means you always have to watch out for right triangles. And where you have right triangles, you're going to have your right triangle toolbox. 5 different things you can do with right triangles. Thou shalt memorize this. The first and most important one. The Pythagorean theorem, leg squared plus leg squared equals hypo squared. Next one. 45, 45, 90. Say it with me. 45, 45, 90. Leg, 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 root 2. Good deal. 30, 60, 90. Short leg, root 3, short leg times 2. And then the infamous and famous so. You saw me in class, you know why I said it like that. And then your last one, and that's to find sides. Then inverse, so spell this correctly, toa, is to find angles. So watch out, whenever you see a right triangle, you need to start asking yourself, which one of these are in play? Not all of them, but one of them. And the only other thing that we learned today is if you have a beach ball angle, which is code for a tan-tan, the arms of a tan-tan angle are congruent. That's it for now. Review that, and I'll see you in class.